Taking their inspiration from a sea creature that can see far better than we can in some respects, scientists are hoping to improve the ability of surgeons to spot tumour tissues and remove them successfully in the operating theatre. The animal in question is the mantis shrimp. Unlike our eyes, which contain light sensors that respond to different levels of three main colours, and that's red, green, and blue, the mantis shrimp eye can see a much wider spectrum of some 12 to 16 different colours. And a team at the University of Illinois have now created a camera based on the mantis shrimp compound eye structure that can do the same thing and see colours that we can't, including into the infrared. The idea is that you can selectively tag a tumour with fluorescent chemicals that we can't see, but the camera can, and that will give surgeons a quick way to tell if they've removed all of the cancer. Adam Murphy spoke to the inventor, Victor Gruev.
We've created a camera that's able to capture many more colors than regular cameras, and we are capturing both color as well as near-infrared. And the near-infrared information is critical for image-guided surgery.
Why is that? Why is it so helpful to have all these extra colors that we can't normally see?
During surgery, most of the time the surgeons are relying on their own visual system, on their own eyes, to be able to perceive where the cancer is, where the tumor is, and ensure that all tumor cells are completely removed. And it's very difficult to make this decision and to make sure that all cancer cells are removed from the patient's body. By adding additional colors, and in this particular instance, we're using tumor-targeted drugs that are fluorescent, and they attach to the tumors, they broadcast a signal or emit light, and help the physicians visualize and ensure that all tumor cells are completely removed from the patient's body.
What does this thing actually look like to use? Is it like it's not a massive camera that you're blocking everyone's view with?
Right. So that was one of the hard lessons that we've learned over the years. As an engineer, you have this fascinating idea that can help the physician, and you go into the operating room and suddenly nothing works. Why? Because you obstructed their view, you obstructed the natural workflow. So it's a very delicate environment you have to work with. You have to understand what the surgeons need. And as a colleague of mine said, you have to be able to solve a clinically relevant problem in a clinically relevant time. So by solving this problem, you got to make sure it's integrated in their workflow. So you cannot just roll in a big instrument when, in fact, you're obstructing what the surgeons are doing. So, our take has been always miniaturizing everything, making sure that these cameras can fit in any operating room. You have to also consider not all operating rooms around the world are the same. Anything, most cases, they're relatively small rooms. They're there to get the job done. So you have to consider all those scenarios and also the cost. One of the things that we've been able to achieve is having a low cost, small sensor that can fit in many hospitals that might have limited resources.
Victor Gruev there, and that work has just been published in Science Translational Medicine.